Hello everybody. All right, here is the answer for the most recent challenge question. We had two rectangles that are similar. They had a scale factor of 4. Remember, you could use k to represent the scale factor, so k equals 4, meaning that this rectangle is 4 times the size of this one, and its scale factor, enlargement, dilation. Okay, so the area of this one was given as 24. So basically, we know that its length times its width must multiply to make 24. I wanted you to come up with possible integer side lengths for the length and the width. So basically you could factor 24 and find out what possible factors there are using integers to equal 24. You could have made your length and width a 1 by 24. You could have made it a 2 by 12. You could have made it a 3 by 8. You could have made it a 4 by 6. For mine, I'm just going to choose 4 by 6. I'm going to say this is 4, this is 6 for the length and the width. But again, any of these integer combinations would have worked depending on how you did it. All right, so if the scale factor is 4, this side here that's 4 is going to be 4 times larger. Now it's going to be 16. If this side is 6, it's going to be 4 times larger now. 4 times 6 is 24. All right. Okay, so now let's see. We're comparing how did the area increase and how did the perimeter increase. Let's get the perimeter of this one. So the perimeter is the distance around the polygon. You got to add up all the sides. The perimeter for this one, for example, is 20. And those are regular units. Now, the area will be 24 regardless of which of these combinations that you used. However, the perimeter will be different depending on which combination you use. So your perimeter might be individual for yours. Mine is 20. The perimeter of my larger one, let's see here, is going to be, what I get? 80 units. And you'll notice that the perimeter is 4 times greater, just like the side lengths are 4 times greater. However, the area is a different story. Oh, by the way, whichever of these you used to get your perimeter, and again, your perimeter might be different than mine, but whatever your perimeter is for this one will be 4 times larger. So if the scale factor is 4 for the side lengths, the perimeter scale factor is also going to be 4. The area, however, is going to be different. So to get my area, I'm going to do length times width. So my length is 24, my width is 16. Let's see what we get here. Looks like we're going to get 384. Well, that is more than 4 times larger. In fact, if you're wondering, well, how many times larger is that? You could always divide 24 into 384 to see how many times larger did it get. It's worth noting that, again, we might have different perimeters. Our areas are all going to be the same, no matter which of these you used. If you make them 4 times larger for this one, and you do the length times the width, you're going to end up with that 384. So let's see, how many times larger did it get? Blank, blank, blank. 24 into 3, no. 24 into 38 goes 1 time. That's 24. 24 into 144 goes 6 times, and there's no remainder. It got 16 times bigger. So the answer was the perimeter gets 4 times larger. However, the area gets 16 times larger. Now, I could also show you a picture to represent how we kind of could tell it's going to be 16 times larger before actually calculating it. So check this out. If this is 6, but then it enlarges to 24, well, how many of them can you fit in there? So you take a 6, you take another 6, you take another 6, you take another 6. You could fit 4 of these going across this way because it's 6 plus 6 plus 6 plus 6. All right, this is 4, but this is 16. So how many of these can you stack up? Well, you could fit 4, another 4, another 4, another 4. And so you basically have 4 of these going this way because it's 4 plus 4 plus 4 plus 4 equals 16. So if we fill out this grid, you could fit 1 there, you could fit 1 there, you could fit 1 there. Here's another one, there's another one, there's another one. Here's one, here's one, here's one, here's one, here's one, here's one. Not that my drawing's the best, but you could see that you could actually fit 16 of these inside of there. So that's how we could kind of tell with the picture that the area was going to end up being 16 times larger in this one than it was in the original one. But again, if you work out the numbers, you could also prove it that way. So either with the picture or with the numbers. Okay, so there's the answer for your challenge question. Stay tuned for the next challenge question coming up soon. Hope you're all doing okay. We'll see you next time.